All right, today we are looking at writing equations of lines, day 2. Today in class we talked about writing the equations of lines, looking at a graph, looking at 2 points that they give you, maybe looking at a point and the slope using the point-slope formula. We looked at several different ways to write equations of lines. Now today we're just adding one little extra thing to it, talking about parallel and perpendicular lines. All right, parallel lines, those are 2 lines that have the same slopes. If they're the same slope, they either rise or fall at the same rate, and therefore those 2 lines will never touch. Parallel lines never touch because they have the same slopes. All right, for example, if one equation of your line is y equals 3x plus 4, a parallel line to that would be y equals 3x minus 6. The slopes are the same. Both slopes here are 3. Okay, the only difference in parallel lines is that their y-intercepts have to be different. They cross the y-axis in different places, but their slopes are the same. Next we have perpendicular lines. Okay, perpendicular lines do not have the same slopes. These slopes are what we call opposite reciprocal. Opposite means if the slope is positive, the other slope has to be negative. Vice versa, if one slope is negative, the other one has to be positive. All right, and reciprocal means just whatever your fraction is for your slope, you'll need to flip the fraction. So the 2 slopes have opposite reciprocal slopes or fractions. Okay, and these 2 lines will intersect and they'll make a 90-degree angle. That's what the word perpendicular means. They will make a 90-degree angle where the 2 lines intersect. For example, a couple of examples here. If one equation of your line y equals 4 over 3 x plus 2, my slope here is 4 over 3, a perpendicular line would have opposite reciprocal slope. So if this was positive 4 over 3, this one's going to be a negative. Positive and negative, opposite. Reciprocal means you flip your fractions. If this first slope is 4 over 3, this fraction has to flip to be 3 over 4. Okay, we're just looking at the slopes. The y-intercepts, doesn't matter what those are. Those can be either the same or they can be different in this case. Parallel lines, the y-intercepts cannot be the same. Perpendicular lines, they possibly can be. Okay, here's another example. What if your slope is not written as a fraction? The slope is just a 4. Y equals 4x minus 3. Well, the opposite of positive 4 would have to be a negative. And if this was a fraction, it'd be 4 over 1. So what's the opposite or the reciprocal of 4 over 1? Reciprocal means flip your fraction. Instead of 4 over 1, my new slope would be 1 over 4. Now notice these have the same y-intercepts. Y-intercepts do not matter when it comes to perpendicular line. They can be the same or they can be different. It does not matter. Okay, they can be the same when you're talking perpendicular. So if we look at a few of examples here. All right, number 1 on our assignment. Okay, it looks similar to what we did today in class. They give us a point and they give us a parallel line to y equals 4x. Well, if I know my line has to be parallel, then I know my slope, my m that I need to use, has to also be 4. If the lines are parallel, then I know my slope. My slope here is 4. So again, we would use the point slope form. So we would say y equals m x minus x1 plus y1. And we'd plug in the numbers. This is my x value, the 5 is my y value. I'd plug those numbers in. Y equals my m, we said was 4. My slope, I know that. X minus 1, that's my x1 value, plus 5 is my y1 value. Now when I distribute my 4, I get y equals 4x. Distribute your 4 to the minus 1, you get negative 4, then there's a plus 5 at the end. And when you combine these like terms, you get y equals 4x, and negative 4 plus 5 is just positive 1. So there's the equation of the line. So we're just using what the information they give me to find the slope. I know that slope has to also be 4. All right, look at 6. 6, my slope needs to be perpendicular to this one. Well, if this slope is a negative, then I know my slope needs to be a positive. If this slope is a 1 over 7, my slope, if I flip that fraction, would be 7 over 1. 7 over 1 is the same as just 7. So once again, we could use our slope formula, and we could use this coordinate x1 and y1, and the slope of 7. So we'd say y equals 7, x minus x1, which is 1, plus my y1, which is 4. And we could distribute here. Y equals 7 times x, 7 times negative 1, and then you got your plus 4 hanging out at the end. Combine those like terms, so you've got y equals 7x, negative 7 plus 4, negative 3. So y equals 7x minus 3. Okay, so again, we're taking the information that they give us to figure out what our slope needs to be. Then once we know a point and our slope, we can use point slope form. Flip it over to the back to number 9. All right, so this says line P can be described by this equation. Now this equation is not in y equals form. Okay, we're going to have to figure that out first. We're going to have to solve this for y equals, put it in slope-intercept form so we will know what our slope is. Line R will then need to be perpendicular to that. Which of those could possibly be perpendicular? So in order to do this, we're going to need to solve for y. All right, so the first thing I would need to do here to solve for y is I'd need to add 8x to both sides. I'm going to come right over here. So I'd have 4y equals, if I add 8x to the right, I'm going to put that in the front, and I'm going to move my positive 12 to the back. Now we divide by 4, divide by 4, divide by 4. So I get y equals 8 divided by 4 is 2, so 2x. 12 divided by 4 gives me a 3. So the original line is 2x plus 3. If my line needs to be perpendicular to that, then my slope needs to be, if this is a positive, my slope needs to be the opposite, so my slope needs to be negative. Now if this was a fraction, it would be 2 over 1. If the original slope is a 2 over 1, the reciprocal slope would be 1 over 2. You'd flip it. Negative 1 over 2 would have to be my slope. So which one of these answer choices has a slope of negative 1/2? Well, obviously not A, because that guy's going upwards. He's positive. It's obviously not B, because he's also going upwards. He's positive. Okay, so my slope would be down 1 over 2. So which one of these is down 1 over 2? 1 over 2 looks more like C. This one looks like it's 2 over 1. D looks like it's 2 over 1, which would not be correct. Our answer there would be C. And that's pretty much all we've got for this lesson. Parallel and perpendicular lines, not very complicated. Okay, we've got some more word problems here, but we can work on these word problems in class tomorrow. So once again, here are the notes you need to know for parallel and perpendicular lines. And just we need to make sure that we understand the difference between parallel and perpendicular, what's happening with our slopes, and what can possibly happen with our y-intercepts.